Hey there and welcome to my very first video ever. I hope this won't be too terrible. Today I would like to explain to you how my script for controlling the Ecoflow in conjunction with the battery storage system operates and what the individual parameter points signify. In the forum, questions keep popping up and I have to admit over time the script has become incredibly complex. That's not so easy to understand anymore what the individual parameters are good for. Sometimes they are also described a bit ambiguously. And I hope that I can provide some clarification on the matter by simply reviewing the configuration and addressing each specific point individually. And I will do my utmost to elucidate my thought process and the purpose of the entire thing. Well, let us delve straight into it and take a closer look at the configuration. So you guys require your Ecoflow in conjunction with the battery. Both necessitate to be connected to the internet so that you can access it with the application. Also, you guys need an installation of IOBroker with the corresponding adapters. Super important, you gotta install the history adapter too so that the script works properly. And you require a power meter that is capable of providing you with the corresponding current consumption from the live circuit in the house. For me, it's the Tibber pulse, for example. He can already communicate with the internet from home. And there's also an adapter for IOBroker that allows you to read the live data. However, you can also accomplish that through the cloud. I composed a small script that enables you to directly and locally access the pulse. You can also discover that information in the forum if you are interested. That is simply the basic requirement that the script needs in order to function properly. And now let's take a look at the configuration. Alright, now we're already in the script. Today we're talking about version 1, 2.3. The relevant part for you, it's recommended to read everything written here. Here you can see nicely how everything has changed and been added over time. But the important part for you to configure starts here. The first point is the email address and password, and that's right here for your login details to the Ecoflow app. The subsequent crucial aspect is the Smart Meter ID. The Smart Meter ID represents the specific point within IOBroker where the live data of your consumption is stored in real time. First of all, you guys need a smart meter that reads live data. That could also be the Tibber pulse. And you have to integrate this into IOBroker, either through an adapter or through a script, however you want. And then you'll find objects at this point. I've already opened it up here at the top. Each adapter creates a department there. And now you guys are looking for the corresponding point. For me, it's like the Tibber pulse, as I said. So I wrote a little script for that, which allows me to read the data live. Then there's SML here, and then there's the PowerPoint. And we need that in the script. To do that, you can click on this little copy symbol here, which appears when you hover your mouse next to the names. I am going to click on it now, then it will be in the clipboard. After that, you can insert it accordingly in the script at this point in time. Please remember that everything has to be preserved. Colons, quotation marks, commas, and so on are really just inserting the string. I require that to be inserted at this location immediately. That is approximately all. Therefore, the connection to Ecoflow and my smart meter has been established. The next point is then the configuration of the PowerStream. In the department of serial number configuration, we handle the setup of all the devices that Ecoflow wishes to add to their product lineup. Starting with the PowerStream, but also deltas or smart plugs can be configured here. So let's start with the PowerStream. The important thing is you can configure not just one PowerStream, but several as well. To do that, this area here would basically have to be duplicated. So basically everything, including these curly brackets here, is a device definition. So if you have two PowerStreams, you just copy this entire section after the configuration and paste it again, change the serial number accordingly, and then it should work. So you can find the serial number in the app. Please enter this one up here exactly as it is in the app. Name is any name. Max power is the maximum quantity of power that your PowerStream is capable of delivering. Currently, German devices have 600 watts. However, it is expected to increase to 800 watts with a future software update. Please input 800 watts here. If you want to limit the performance, don't use this point for it, but always input only the maximum power of your device to ensure accurate representation. The subscribe point is used to determine if the script should retrieve all data from the device or not during its execution. even those that are not relevant for control. When it comes to regulated power streams, please always set it to true. Then you also have access to all the data within the IOBroker regarding objects that are provided by the power stream and can be accessed. For the type, you also need to include PS here in PowerStream, no exceptions. With regards to regulation, you have the option to temporarily take the power stream out of regulation if needed. You also have the option to configure that per power stream. If you decide to set it to false, then it will be turned off. Otherwise, please simply leave it as it is. You can definitely instruct the script from the outside to cease regulating, for instance. When you're charging your car or when you want to buy cheap electricity from Tibber, for example, because it's currently affordable. For automation, a state is necessary. In this state, you can specify the desired action of the power stream when this regulation is deactivated. Should he then completely shut off the feed-in? Should he preserve a specific performance measurement? Enter that here. So if you, for example, I'm saying I still want the 100 watts to be fed in, even if I turn off the regulation, then enter 100 watts here. Then there are two more options. The first one is -1, then the current performance doesn't change. Or -2, then at this particular moment, when the power stream is turned off, it switches to battery priority mode. That means that primarily the battery is charged with everything that is available. And only when the battery has reached the charging maximum, usually 100%, will what comes in through the PV modules be fed into the grid. Which of course also makes sense. The point hasbat should always be set to true here if you have connected a delta. If you were to connect a power stream without a battery, you would set that to false. That actually causes the script to automatically set this power stream to the maximum feed-in power. Because if there is no battery, it doesn't make sense to hold anything back and it will no longer be taken into account in the regulation. Then there are 2 points referred to as battery priority over utility supply on and battery priority over utility supply off. These points are utilized to determine the battery charge level at which the power stream should either switch to battery priority mode or deliver its full power supply, depending on the specific requirements. And he performs that action when he reaches this battery level, continuing to do so until the off state is finally reached. In this particular case, the battery is charged up to 99%, and then it switches to battery priority mode, where it stays until the battery drops back to a charge level of 94%. During this time, the device prioritizes the use of battery power over other sources of energy. When that happens, he switches back to normal mode of operation. If you possess this pre-off demand point, then it has the potential to be interrupted in this state, where the thing is in priority mode and requires immediate attention or action. And that is when your house makes another service request. That signifies that there is no longer an excess, so your house is no more generating more solar energy than it requires, but it is once again requiring energy. And in the event that it surpasses this threshold, which in this specific case is set at 30 watts, then the priority mode is promptly terminated and the device resumes feeding in a regulatory manner, just like it would in the normal state of operation. The 2 points down here are designed to ensure that in the lower area, when the battery is discharged, it does not continue to be charged at full power, but rather that the feed-in power is limited in order to prevent overcharging and potential damage to the battery. You have the option to utilize that at this very moment in order to regulate and control the performance of the power stream in a general manner. So if you're stating that my power stream should not deliver the complete power of 600 watts, but rather only a maximum of 400 watts, then you could accomplish that with these 3 points, for instance, by indicating when my battery power is at 100% or less, and we do not even turn it off. We do not make a big deal out of it, we simply let it be without drawing attention or causing any fuss. That means it always applies. So your battery is always a little 100% and will never reach the point 101%. And if you were to enter a 300% here now, that means that your power stream will only deliver a maximum of 300 watts and nothing more. Now you have a second power stream. Here's how it went. You have now finished configuring the first one, just as you imagined it. Then you guys can just take this and copy it and then paste it right here below. That appears neat and tidy. Then you simply need to make adjustments to the serial number located here. and perhaps provide it with a new name or designation. And then you guys have already configured 2 power streams, but we don't want that in this case. So let's just undo the whole thing and let's take a look at the next point. So in this department, we will then configure additional Ecoflow devices. You can also easily accomplish this by specifying the serial number, providing it with a name, and entering the corresponding type of the item. That is the information that you guys need to enter, as indicated by this list that is located up here. If you want to give the system a break, then just subscribe to Falls here, because these devices send the deltas with an incredible frequency of data. What can cause an overload in the system? If you guys are receiving error messages indicating that the script is writing an excessive number of set states, then it is likely due to a delta configuration that is set up here in the dizzies. You all can set this limit, which I think is set to 1000 by default, but you all can also increase it. If you all take a look at the entry fee in the forum, it is described how you all can increase it. If you have any more deltas, you can copy and duplicate this part to configure more devices. If it starts and then stops running, please take a look and increase the limit. So if you have any additional deltas, you can simply copy and duplicate this part, like paste it below once more to configure more devices. The next point, additional power, let's leave that aside for now. I want to cover that in a later video again. In this case, it is about controlling devices from other manufacturers using the script as well, in order to include them in the control process. Once you have configured your devices, the script works pretty well with the default settings. But let me go over the advanced settings once again, because here you have the ability to influence the behavior and the way the script operates once more. So let's go through the points here one by one. First 2 points, smart meter timeout in mins and smart meter fallback power, determine action when smart meter no longer provides data. In this case, if the smart meter doesn't provide any current data on your household consumption for 4 minutes, the PowerStream injection or the total injection will be set to 150 watts. And then you wait until fresh data comes in, so you can adjust the measurements accordingly once again in order to ensure accuracy and reliability. The interval determines how often measurements are taken. Here it's important that it's not chosen too small, because after the corresponding settings have been sent to the PowerStream, it takes some time until these measurement data, or the actual data that the PowerStream provides, are available again in the script. That can be a little different depending on what kind of configuration you have, how your network works, how fast your smart meter operates, and so on. However, you should not generally choose it too low. Well, I would not recommend going below 10 seconds at this point in time. Regulation true and regulation state are responsible for determining whether the script can be turned on or off from the outside, meaning through external scripts or other systems, and defining its behavior during the initialization process. The way it's currently set up here, regulation true means that during the first launch, the very first launch, before the state, which is the regulate object, is even created, the script is already activated. If the script is started for the first time and the object regulate state exists, then you can enable or disable the script through this object, which you can find under Objects. The subsequent point determines the behavior of the script when multiple power streams are configured in the system. So how should energy be distributed then? There are 2 fashion styles. One's mode 0, that's balance. So the script attempts to evenly distribute the performance across all available power streams to the greatest extent possible. That applies to the battery charge as well. So there they also try to achieve as equal battery levels as possible when charging the battery. The same applies to unloading. In the serial stage, it is like this. The first configured, meaning the first power stream that you have set here in the configuration, will be loaded and discharged first in the order of their configuration. And only when the performance of the initial power stream is no longer adequate to fulfill your household requirements, then the subsequent one in line will be utilized. That is amazing. Base power offset. Individuals frequently inquire about the details regarding that. It's just that naturally, due to certain fluctuations in the rules, there are always situations where energy can be fed back into the grid. To maintain a minimal share, there is an option to establish a basic consumption or purchase requirement at this point in order to keep it as low as possible. By utilizing a base power offset of 30, the device makes an ongoing effort to draw a constant 30 watts from the public grid, relying on battery and solar power to meet any additional energy requirements beyond that threshold. Extra power is a characteristic in the script that attempts to extract a small amount more when the maximum power from the PowerStream is attained. Essentially, this device possesses a power capacity of 800 watts in this location. In the event that the entire power is directed towards the battery, the script then attempts, in a gradual manner, to supply a portion of the energy generated by the PV modules into the household network. And at what power level it initiates going into the battery, that is what you ascertain at this juncture. So if you have now set the maximum power of your PowerStreams to 600 watts, then this 10 here means that it starts at 590, which is 600 minus 10 watts of battery power, and tries to draw a little more and feed it into the house network. The next point determines the flashback time, in which the script looks back and takes the lowest value of your consumption to adjust the regulation with it. By default, it is configured to utilize the history adapter to store all measurement values in it, and subsequently determine the lowest consumption value recorded within the specified time frame of the past minutes set in this configuration. And that is precisely what the regulation is aimed at. That simply makes sense because there are significant fluctuations, and therefore the control is not too jumpy and potentially jumps and feeds in. It is a genuinely useful thing to have in place. Here, only the lowest consumption value is taken. Short-term consumers don't completely throw the regulation out of whack. But if you always want to retrieve the value live and you don't have such problems, and you just want to react quickly, then you can set this value to 0. Then the value will no longer be retrieved from the history adapter, no average values will be determined, and the current value will always be taken. But y'all will find out that this ain't gonna lead to a calm regulation. With the next point, you can determine whether, as just described, it is done with the lowest value of the last 2 minutes, or whether an average value should be calculated. For example, at the moment when I insert the number 1 here, I use the average value because I have a larger inverter that regulates very erratically, so peaks of plus 100 and minus 100 watts are nothing special. To achieve a reasonable result with the script, I took the average value here for somewhat reasonable results. In normal cases, and to ensure smooth operation for you all and avoid the same issues I experience, I always suggest working with the minimum value. Always make sure to leave a reconnect minute for you in that manner. Therefore, if, for any reason, no data is received for a period of 30 minutes, then the entire script will perform a reset operation. Here you have the option to set the object path where all objects of the script will be saved. This can be very convenient if you want to test with a different configuration without disrupting your existing data. You can simply duplicate the script here, save it under a different name, specify a different path like 2 here, and then initiate it. The entire script will be completely regenerated as if it were completely new, and you will once again find all the data you configured under objects in this specified path. Therefore, you can confidently attempt an alternative option without jeopardizing your current data. You do not have to worry about these 2 values either. Typically, we retrieve the location data from the IOBroker installation at this location. Currently, they aren't being used. That is only intended for later, with a sunrise, a sunset, and similar things, to be able to work. So let's just ignore that for now. That should be it for the configuration points for now. There are still other points to consider, like how to handle the surplus charge here, or even the implementation of external states, so that you can change configuration points from the outside. But I don't want to discuss that in the first video now. We can go over that again in a separate video for sure. If you guys want that, then please write it down in the comments below. If you have configured and started the script now and want to check if everything is working, it makes sense to take a quick look at the objects. There is the object path that we have just set. Here you can see at a glance whether the configuration is working up to this point in time. And the important points here are the real power. Real power represents essentially the actual consumption minus what is diverted to the battery or comes as photovoltaic power from the roof, so it is what your devices actually consume. And if that gets updated on a regular basis, as you can see in this example, then that indicates that your script is correctly configured and able to gather the appropriate data. Moreover, at Total PV, you also have the ability to see the total solar power that is currently being generated at this moment in time. This value also has to change regularly, so if you can see the changes like here, that's already a very good sign. Moreover, you all have the ability to observe the changes that the script sends in the application. If you go to your PowerStream there and look at the household power demand point in the settings, you should easily notice that the script dynamically adjusts this point in real time, providing accurate and timely updates. Of course, it's set to 600W if you're using more than 600W, otherwise it should just match the household consumption. Later in the smart meter, you can then verify and confirm if your script also successfully achieves this desired base power offset value. Once all of that is ready, then the script will start running for now, and then maybe you can start looking at the next configuration points. So that was about 20 minutes of very dry material. I hope I could make it a little easier for you to get started with the script. And if not, you can still use the video as a sleep aid, but if you all want more information, don't forget to leave me a comment. In the video description, I'll provide the important info again, including the link to the forum where you can find and download all the info about the script. Also, I've got a few links for you to the necessary devices like Raspberry Pi, Ecoflow devices, smart meters, etc. Added, if you buy through that, I'll get a little commission that helps me to continue the project then. And as I've learned from the other YouTubers, if I've helped you, give me a thumbs up and hit subscribe so you don't miss any new videos from me. In future videos, we could discuss controlling devices from other manufacturers, as I hinted, using the script to ensure seamless compatibility. Enjoy setting up the script and see you next time.